Hello, good day viewers. You are welcome to my YouTube channel. We are going to be starting with the alternative to practical today for NECO. You know, NECO, they are supposed to perform the practical, but because of one reason or the other, they are not going to be doing the practical. They are going to be giving alternative to practical for the NECO. Now, I'll be showing us this morning, I'll be guiding us how to go about it. I know a whole lot of students, they have been panicking already because this is the first time NECO will actually be giving them alternative to practical. But I'm going to show us, just calm your nerves, I'm going to show us, I'm going to guide us how we are going to go about the alternative to practical. Now, the difference, let me quickly talk about the difference between the alternative to practical and the real practical. You know, you are supposed to perform the practical chemistry, which is the volumetric analysis for the first question and the qualitative analysis for the second one. But now you are going to be doing alternative to practical. What is the difference between the two? The difference is this. For your practical, if you have to perform the real practical, you'll be given apparatus like burette, like retort stand, your conical flask, and you work with a particular concentration of acid. But now, you are not performing the practical because the aim of you doing the practical is that you want to get a tighter value. What do we mean by that? You want to get the average volume of acid that is going to neutralize a particular base. But now, you are not going to be giving that apparatus, so it is stress-free because you know, if you are performing the practical, there are precautions to follow. You know, you have to record the burette readings. Sometimes there might even be error in you recording your burette readings. But for alternative to practical, you are not doing all that. The volume of acid used might be given to you, or you might be given a table already where you are just going to subtract and get your volume of acid used. So for the real practical, you are getting the volume of acid used yourself. But for the alternative to practical, they are giving you all what you want to get your volume of acid, or the volume of acid will even be in the question. So, but for today now, we are going to be looking at two different questions, and we are going to be looking at how we are going to answer them step by step this morning. So just kindly pay attention. Now we have the first question. The first question, don't forget, you are doing alternative to practical. The first question here I have, the table below shows the result of the titration of 25 centimeter cube of 0.02 mole per dm cube KOH with HCl solution. Now, you will agree with me that if you are doing the practical, you are supposed to actually get these readings yourself. You are supposed to get these readings yourself. But now they are giving you this table because it is an alternative to practical. This table has been given to you already, where you have the burette readings. They have given you final burette readings to be this, first to be this, second to be this, which means that this table is telling us that they performed 3 titrations. One is the rough titration, while they have the first and the second now, as per the table they gave us. They now said the final burette readings is 25.20. They said the first reading, the rough readings rather, is 25.20. The first titration is 23.70. The second is 45.10. While the initial burette readings, you have this value, you have this value, you have this value. Now, what they now ask us to do is, the number one question, if you look at it, is a copy and complete the table. Of course, they are giving you this table. You are supposed to do this yourself, if you are performing the practical, but now it is stress-free. All the final burette readings has been given, the initial burette readings has been given. So how do I get the volume of acid used? What I will do is, to get this value, I will subtract the initial burette readings from my final burette readings, and if I subtract this, I'll be having 25.20. We'll be having 25.20. For the second one, I have 23.70. Subtracting this because that's how you get the volume of acid used here. 23.70 minus this. Please, if you are not sure, you can use your calculator. You don't need to actually be in haste. You can use minus 1.20. We have 22. We have 22.50. Nobody is going to penalize you for that. You can use your calculator. Then we have 45.10 minus 22.50. So we have 22.60. You can see, very, very easy because it's an alternative to practical. So the first question is copy and complete the table. We have done that. Copy and complete the table. This is the value for the first table. This is the value for the second table. This is the value for the third table. Now the next question is calculate the average titer. What do you mean by that? They ask us to calculate the average volume of acid that is used. If you look at the rough, the volume of acid used for the rough is 25.20. The first one is 22.50. The second one is 22.60. Because this is rough, you can see the value is a bit higher than the rest two values. And that's the reason why, because the difference between the value, the rough and the first and second is so much, we don't use our rough. So for me to calculate the average titer now, I will just say the average, we have started now, the average titer now, the average titer will be equal to this, which is 22.50 plus this plus 22.60. If you look at these two values, you see they are very close, and that's the reason why we are picking these two. And if you have a third titration too, you can say the first, the second plus the third, then you look for the mean. So because I'm using 2 now, this will be divided by what? By 2. So the average titer, or the volume, the average volume of acid used will be, I have our calculator, 22.50 plus 22.60. Then we have divide by 2. We have 22.55 centimeters. Very easy. The alternative to practical is very, very easy. So calculate the average titer. This is the average titer. So the average volume of acid used to neutralize the 0.02 mole per dm cube KOH is 22.55 centimeter cube. That's the average titer, which is the Roman figure 1. Now the second one, they said you should look for the concentration of KOH in gram per dm cube. Let's go back to the question. They said the table below shows the result of the titration of 25 centimeter cube of 0.02 mole per dm cube of KOH. Now, for your concentration in gram per dm cube now, don't forget you are giving your concentration in mole per dm cube, and you can actually calculate your molar mass from this very particular KOH, because you are giving K already to be 39, you are giving O already to be 16, you are giving the atomic mass of H already to be 1. So we use this general formula, which is our mole is equal to our mass over our molar mass. So from there, we calculate the molar mass of KOH first. There we have the molar mass of KOH will be equal to, they are giving us our K, potassium, to be 39 plus 16, they are giving us plus 1. That will give us what? 39 plus 16 plus 1. That will give us 56. Give us 56 grams per mole. Because we are looking for our molar mass. The molar mass of KOH now is 56 grams per mole. Don't forget that we are looking for the concentration of KOH in gram per dm cube. They are giving us the mole already. Giving the mole already to be 0.02 mole per dm cube. Can you see that? So if I'm looking for my mass now, I have to make mass the subject of formula. So my mass equals to my mole times molar mass. So from there, we have our mass to be, what is our mole? 0.02 times, what is our molar mass? 56. 56. So we can have 56 times 0.02. So we have 1.12 gram per dm cube. Very easy. Very easy. So this is our concentration of KOH in gram per DMP. We move to the next question. Concentration of HCl in mole per DMP. Concentration of HCl in mole per DMP. If you look at the information about our HCl here, we are not giving the mass. Don't forget, we are not giving the mass here. We are not giving the mole here, which means this formula is not possible. Look at this. Mole is equal to mass over molar mass. You can only use this to calculate your mole when you have the mass and you have the molar mass. So, but now they are not giving the mass of this. Even you cannot even calculate the molar mass because they didn't give you the atomic mass of chlorine, which means we are going to use another equation, another formula for titration, which is CaVa over CbVb, which is Na over Nb. What is our Ca? Our Ca is the concentration of acid, our Va is the volume of acid, our Cb is the concentration of base, our Vb is the volume of base, and our Na is the number of moles of the acid that can be gotten in the equation of reaction they gave us, and our number of base that can still be gotten again from the equation of the reaction they gave us. So we can have this like this. Let's get all the parameters before we start. Volumetric analysis, which is CaVa over CbVp equals Na over Nb. Do we get that now? Okay, what are these representing? We have Ca, which is the concentration of acid. Don't forget, they said we should calculate the concentration of HCl. HCl here is the acid, and that's what we are looking for. So we have Ca, we don't know it. Our Va now is our average titer, or the volume of acid used. You can say it is average titer or the volume of acid used. And the volume of acid used, according to our table, is 22.55 centimeter cube. Okay? The concentration of our base, look at the question, we have that already. The table below shows the result of 25 centimeter cube of this KOH. So KOH is the base. So this is the concentration of our base to be 0.02 mole per dm cube. How following? Okay, the volume of base. Let's go back to the question. They said the table below shows the result of the titration of 25 centimeter cube of this, which is the base. So the volume of the base is 25 centimeter cube. So our number of moles of acid, I've told you that, and we got it from the equation of reaction. And what is the equation of reaction? HCl plus KOH to give KCl plus H2O, which is what? And the number of moles of HCl. Here, number of moles of acid, this is the acid. The number of moles is 1. We have 1. Number of moles of acid is 1. And number of moles of base, this is the base also. This is what it is 1. Because it's 1 mole of hydrochloric acid, 1 mole of potassium hydroxide. If you have 2 here, it means the number of moles of acid will be 2. If you have 2 here, it means the number of moles of base too will be 2. But now, according to the equation of reaction we have here, you have the number of moles of acid to base to be 1 to 1. So from here, it looks very much easier and interesting. We slot in all the parameters into the equation. Where we have what? Our Ca now is what we don't know, times our Va, that's 22.55, over our Cb, that is 0.02. Are we okay? And our Vb is what? 25 equals 1 to 1. Are we following? So from there, we look for our Ca. So our Ca will be, we are cross multiplying now. Our Ca becomes 0.02 times 25 times 1 over, we have 22.55 times 1. Okay? So from there, our Ca, use our calculator to get the value for our Ca now. Here we have 0.02 times 25 times 1 equals, divide by 22.55 0.55. So we have 0.022. Approximately we have 0.022 mole per dm3. Okay? That's the concentration of our acid. That's the concentration of our acid in mole per dm3. Now we need the concentration of our base. Concentration of our acid in gram per dm3. Definitely we can have our chlorine to be 35.5. All those ones will be given to us. The atomic masses of those elements will be given to us. We don't need to cram them. Will be given to us. So from there, we have concentration of ACl in gram per dm3. In gram per dm3 means now we are looking for the mass concentration of acid. So our mass is what we are looking for. Do you see that now? Our mole now is what? Is 0.022 mole per dm3. And our what? Our molar mass now. Our molar mass is what? For HCl, you have 1 plus 35.5. This given to us in the question. HCl is what? Is hydrogen is 1 and chlorine is 35.5. So we are looking for the molar mass. We are adding the atomic masses together, and here we have 36.5 gram per mole. So from there, you know, we have mole is equal to mass over molar mass. Now we are looking for mass. So what do? We cross multiply. So we have mass will be equal to mole times molar mass. So our mass will be equal to mole times molar mass. So we have our mass to be equal to what? 0.022 times 36.5. So we have this times 36.5. Then we are going to be having 0.8. Our mass now will be 0.8. Let's say 0.9 gram per dm approximately. That's that. I hope you are following. So that's how simple and easy our alternative to practical is. Then the last question now, they said the number. The last question now, they said the number of hydrogen ion. The last question. The last question now says the number of hydrogen ion in 1 dm cube of the HCl solution. The number of hydrogen ion in 1 dm cube of the HCl solution. Don't forget your acid. The definition of our acid is the number of hydrogen ion in what? In 1 molecule of an acid. So we have this now. Okay. From there, our dissociation reaction for HCl will be HCl equal to H plus Cl, and that's our dissociation reaction now for HCl, which means that 1 mole, please follow me, 1 mole of HCl, don't forget you are looking for hydrogen ion, we give 1 mole of hydrogen ion. Give 1 mole of hydrogen ion. Okay, from there now, from our calculation now, what is the mole of HCl in the calculation? You have the mole of HCl here to be 0.022. So which means if 1 mole of HCl is this, is 0.022 mole will be equal to 0.022 mole. Yes, because if 1 mole of HCl is equal to 1 mole of this, definitely 0.022 mole of HCl will give us 0.022 mole of hydrogen ion. Is that okay? Now, but don't forget that 1 mole of any substance is equal to 6.02 times 10 raised to the power 23 what? 23 ions. Are we following? Okay, 1 mole of this is equal to 6.02 times 10 raised to the power 23 ions. Now, for this mole now, what will be the what? Number of hydrogen ion that will be there. So we have 0.022 mole will now be equal to what? X. Do we get that now? So our X, which is number of hydrogen ion in this, will be equal to 0.022 times 6.02 times 10 raised to the power 23. So from there, our calculator will now be, from our calculator, we have 0.022 times 6.02. So we have our number of hydrogen ion there now will be X to be 0.132 approximately times 10 raised to power 23. And that is all for the first question. You can see it is very, very easy. Our alternative to practical is very, very easy. I mean it. Our alternative to practical is very, very easy. Now, if you look at the second question now, that's the first question. Look at the second question. We are going to go about the second question too very quickly. Go about the second question. We have A is a dilute tetrasulfate 6 acid. B contains 1.50 gram of sodium hydroxide per 250 centimeter cube of solution. 25.0 centimeter cube of B required. This 15.5 for complete neutralization should be 15.5 centimeter cube. The unit is very important. Centimeter cube for complete neutralization. Now, if you look at the difference between this and the first one is that the first one, they give us a table for us to complete it. If you notice that they give us a table, the first question for us to complete it. But now look at this second question, it might come in this way. You are not given a table, but the title value will be in the question. It makes even the question to be more simpler. So for this one now, we have the title value already. Let's read the question again. A is a dilute tetrasulfate 6 acid. B contains 1.50 gram of sodium hydroxide per 250 centimeter cube of solution. Okay, 25.0 centimeter cube of B required this. So the volume of acid needed now to neutralize this volume of base is this. That's the volume of acid, which is our title value. From there, the calculation remains the same. They said we should calculate concentration of B in mole per dm cube. Please follow me. Please follow me. Very, very important. Look at this. Concentration of B in mole per dm cube. In mole per dm cube. But if you look at B here, contains 1.50 gram of sodium hydroxide in 250. But now they ask us to look for it in what? In 1000, because our 1 dm cube. Because our 1 dm cube is equal to what? 1000 centimeter cube. Don't forget. So instead of in 250 now, they ask us to look for the concentration of B in mole per dm cube. So I will say if I have 250, if 250 in 250 centimeter cube, the mass is what? Is 1.50 gram. It means in 1000 centimeter cube, which is what they asked us to look for, mole per dm cube will be equal to what? X. So my X becomes 1000 times 1.5 divided 250. Can you see that now? So our X here will be 1000 times 1.5 divided 250. Then we have what? 6 gram. So in 250 centimeter cube, we are going to have 1.50 gram of sodium hydroxide, but they asked us to look for it in 1 dm cube, which is 1000 centimeter cube. So we have this, we are going to have 6 gram. Then from there, we can have concentration of B in mole per dm cube. Now, very, very easy. That one too is very, very easy. Very, very easy, just like the first one. Just need to pay attention and try to just practice them. Then I'm sure we'll be bringing with a whole lot of confidence for the exam. Concentration of B in mole per dm cube. Don't forget, we are looking for the concentration of B in mole per dm cube. The first thing I will ask myself, I'm looking for this in mole per dm cube. The formula for our mole, do you still remember? Mass over molar mass. Do we have the mass of B? Yes, 6 gram. Okay, that's good. Do we have the molar mass of B? They gave us B to be sodium hydroxide. Fine. And they are giving us sodium, the atomic mass of sodium, atomic mass of oxygen, atomic mass of hydrogen. So very interesting. So we can still go about using this. Mole equals mass over molar mass. Very easy. Very easy. So our mole becomes, the mass is 6 gram over the molar mass. Now you can calculate that. Please try and show all your workings. Molar mass of this, we have 23 plus 16 plus 1. We have been given in the question. Sodium here is 23. Sodium here is 23 atomic mass. Oxygen is 16 and hydrogen is 1. So we are going to have 40 gram per mole. Very easy. So we have 40 gram per mole. This cancels this, the gram. Then we have our mole to be 6 divided 40. 6 divided 40. Then we have 0.15 mole per dm. Very easy. Just like the first one. But the difference between that is the first one they gave us a 1 dm cube. That's why we don't need to convert. But look at this. They gave us this in 250. So, and they asked us to look for concentration of B in mole per dm cube. If that's asked us to look for concentration of B in mole per 250, then we don't need to do this. But they said in mole per dm cube, definitely we need to do this to get the gram. Very easy. Then we have the next one, which is the number 2, concentration of A in mole per dm cube again. We move to the question. A is a dilute tetraoxosulfate 6 acid. We are not giving the mole of A. In fact, the atomic masses of likes of sulfur is not given, which means we still use this formula because we cannot use this. We don't have the mass. We are looking for the mole. We don't have the mass. We cannot look for 2 unknown at the same time. We get that. So we are using this again. So we are familiar with that already. CAVA over CBVB equals NA over NB. We are familiar with this already. So concentration of A, dilute tetraoxosulfate 6 acid. So that's what we are looking for. That's what we are looking for. We have, okay, Ca to be this. That's what we are looking for. The volume of acid now in the question is being given of B required 15.5 centimeter cube. So we have 15.50 centimeter cube. Very interesting. We have concentration of base. We have that already. That's what we have gotten, 0.15 mole per dm cube. You can see that. Very easy. The volume of base, we have that. Of solution, 25.0 centimeter cube of B. And what's the B? The base, which is sodium hydroxide, of 25 centimeter cube. Please read the question. Most times it is 25.0 centimeter cube or 25 centimeter cube of the base. But sometimes you can have 20.0 centimeter cube. Yes, so read the question very well to know the volume of base. Don't just assume it is 25. Read it and be sure it is what? It is 25. And we have our number of moles of acid. Number of moles of acid. That one will be gotten from the equation of reaction. Where is the acid here? H1. That's H2SO4. We have 1 mole of H2SO4 and we have 2 moles of sodium hydroxide. So number of moles of acid is going to be 1, and number of moles of base according to the equation of reaction I've told us. That one can be gotten from the equation of reaction. That's 2. So from there, we look for our Ca now. Our Ca times, what is our Va? 15.50 over, what is our Cb? 0.15 times, what is our Vb? 25 equals Na, that's number of moles of acid, that's 1 over 2, 1:2. So from there, we have our Ca to be 0.15 times 25 times 1 over 15.50 times 2. So our Ca becomes very fast. It becomes 0.15 times 25. That will give us 3.75. Plus 3.75 over, we have 15. Please, you have to be very careful when you are actually calculating and 31. So our Ca becomes 3.75 divide 31. So we have 0.121 approximately. Can you see that? It's very easy. Wow. the alternative to practical is easier than you think, and I'm sure you are following. Very, very easy. It's easier than we think. It's easier than we think. Then the last question now. Number of hydrogen ions in one DMP of the solution. They are still referring us to the one we did. It's just like the one we did the first time. So which our tetraoxide 6 acid now, we should be able to write that as H2SO4. So the dissociation reaction will be what? 2H plus SO4 2 minus. So we have 1 moles of tetraoxide 6 acid giving us 2 moles of hydrogen ion and what? And 1 mole of tetraoxide 6 ion. So what is the mole of H2SO4? Don't forget 1 mole of this is giving what? 2 moles of hydrogen ion. Very interesting. So what is the mole of H2SO4 that we have? H2SO4 is the acid, and the concentration is what? Is this that we have got. So if 1 mole is equal to 2 mole of this, then I have 0.121 mole to be what? To be X moles of this. Okay? So from here we have X equals 0.121 times 2. And that gives us what? 0.121, 0.121. Please, you have to be very careful. Times 2 equals what? 0.242 what? Moles of hydrogen ion. But don't forget that our Avogadro's number, very, very important. Our Avogadro's number tells us, that's why they have given us in the question. Our Avogadro's number, we have 1 mole is equal to 6.02. I've done that here before, times 10 raised to the power 23 what? Ions. So our 0.242 will be equal to X. Very easy. So very, very easy. Just take your time, practice it, and I'm telling you, you'll be bringing with a whole lot of confidence for the exam. You don't need to panic. So we have X now will be 0.242 times 6.02 times 10 raised to the power 23. So from there, we have 0.242 times 6.02. So we have X equals 1.457 approximately times 10 raised to the power 23 years. And that is the answer to those questions. So if you look at it, you see the alternative to practical is easier than even the practical, because all what you need in the question are being given. So what you just have to do for this very particular alternative to practical is just watch this video, study it, take your time to practice, and I'm telling you, it will be easier. So if you have not actually subscribed to this YouTube channel, please endeavor to do that, and you can click on the notification bell so that when we drop exciting and educative videos like this, you will get them. So thank you.